So we've got all of our conditions checked, okay? Now we need to calculate our test statistic, and we haven't done any of the work here, so you're going to have to write down all the p-value stuff here. And this is a good review of a two-sided test. So our test statistic t is equal to d bar, okay? That is what we're writing as x bar sub d, same thing, minus the hypothesized difference. The hypothesized difference is always what you get from looking at your hypotheses. What number is in our hypotheses here? 0. The hypothesized difference is 0, no difference. Divided by the standard deviation of the difference, divided by the square root of n of the difference. You have degrees of freedom, n minus 1. So we are going to go through our entire p-value. So first of all, the probability that our observed difference, x bar of the difference, is not equal to our test statistic, our observed value, our sample value, 22.9. So what is the probability that our mean difference is not equal to 22.9? Okay, now we can't do a not equal to probability if we're going to work it all out. So what we have to do is we have to say 2 times. Now, can we use our test menu? You can use a test. I'll do that after I do this. So this is really 2 times the probability that the mean difference is. Now I need to decide. Should it say less than or greater than 22.9? Because the not equal to, that's the two-sided. Okay, remember on our picture, we're doing a two-sided t-test. The t-distribution, remember, looks similar to a normal. And so we want these values above and below. Okay, so not equal to, we have to pick the less than or the greater than one. So which one makes sense? Greater than or less than? And we're comparing it to 0, basically. Which was bigger? The first one was bigger, right? The first school, our average difference was positive, so we go greater than. If our average difference was negative, our mean difference was negative, we would go less than. This is a positive difference, so we go greater than that. What if it's more positive than this? As extreme or more extreme? Okay, so now the 2 times is the very last thing you do. Now I'm going to ignore that 2 times until I have the p-value. So now I use this formula to calculate my test statistic. T is greater than, okay, the mean difference was 22.9. That's what I observed in my sample. Minus 0, which is the hypothesized difference, all over the standard deviation of the difference, which from our other page was 24.3 divided by the square root of 7. And our degrees of freedom here is going to be 6, 7 minus 1. So now I'm going to go through and calculate this. 22.9 divided by, begin parentheses, 24.3 divided by the square root of 7. And we get 2.493. So this is 2 times the probability that t is greater than 2.493. Now, if we go up to our picture, this is, whoops, 1, 2, I don't know, these aren't really good, but this would be 2.493. And we want to know what's the probability that I'm greater than that, and the negative one too. And that's how we take care of times 2. So now how do I type this into my calculator to get the p-value? You got TCDF. So now I'm going to go 2 times TCDF, and your lower bound, so second distribution, TCDF, number 6. And my lower bound is the 2.49. And my upper bound is infinity, and my degrees of freedom is 6. And then I take that p-value times 2. And so my p-value for this problem is 0.047, and my alpha level was 0.05. So what do I decide to do? Well, it's less than, so I'm going to reject the null. Okay, so since the p-value is less than alpha, we reject the null and conclude that there is a difference, a mean difference in the SAT scores at the two schools. We weren't asked to say which one is better, we were just asked if there was a difference. So I could have just done this whole thing on my calculator, okay? You have to show all these steps if you're going to do it by hand. If you were going to do this on your calculator, you would have gone to Stat, over to the Test menu. So Stat, over to the Test menu, and you would have wanted to do a one sample t-test. Basically just a t-test. So basically you're just doing a t-test, number 2. So one sample t-test, so just a t-test. And I actually have my data in there. And the hypothesized difference is 0. The list, my list is actually in list 3. Wherever you put your data, mine's in list 3. And then you can just go ahead and do the not equals. And then you can calculate it. And so if you're going to do it on your calculator, you still need to say the probability that the difference, the mean difference is not equal to 22.9 is equal to the probability that t is not equal to. Okay, then you need to go here and say, well, my t was, I did something wrong. So stat tests, t-test. Okay, so yeah, well, let's go to list 4. Yes, because I don't even have a list 1. So calculate. So now this is better. So now it tells you your t, so you need to write t there, 2.488. Slightly different than we got before, right? Slightly different, because the calculator didn't round anything. And then that would be the p-value. Then I can just write my p-value is equal to 0.047. Now somewhere you have to write the formula. So t is not equal to the mean difference minus 0 over s over the square root of n. So you have to put that formula somewhere, whether it's off to the side or in the process. That's the formula that was used to calculate this. If you're not writing formulas down when you're answering the questions, you're not going to get points. All right, so the p-value is still 0.047, alpha was still 0.05, you're still going to reject the null, but this is the work you have to show if you're just going to let your calculator do the test for you. You do need to know what test to pick, that it's just a t-test, because at the beginning we said that this is just like a one sample t-test. All right, so now at the top of the next page, what if we didn't know that the data were paired? What if someone just gave you that table and said, compare these two schools? Okay, and we did 2 independent samples test. So I'm not sure where this data came from, but it says we wouldn't see the difference in the schools. It said if we did a 2 sample test, and I'm going to do that. Actually, if you see, I'll show you that I did this. I entered the data in my list 2 and list 3. So I entered the 2 original data in there. And if I just go to stat and I do a test, and I don't realize they're paired. I didn't realize they paired them up. I just wanted to know if there was a difference in the school. So I decided to do a 2 sample t-test. Okay. And so I go down to 4 2 sample t-test. And I have the data in list 2 and 3, and I'm doing a not equal to, it's not pooled, and I'm going to calculate it. And then it gives me that my t is 0.234, which is slightly different than this. And then my p-value is 0.819. And my degrees of freedom would be about 12. So in this case, my p-value would be way greater than alpha, and so I would fail to reject the null and say there is no difference. So in this case, I would fail to reject the null, not evidence of a difference between the schools. So the matched pairs test actually was better able to identify that there was a difference because you're finding the difference first. But you can only do a matched pairs if you purposely match them up by some meaningful way to start with. So when we pair the subjects and subtract their scores, the variability of the individual scores is eliminated, mostly, since we're comparing students of roughly the same ability. The only variability left is due to the difference in the schools or randomization. And the hypothesis test allows us to decide if the difference is due to randomization variability. So removing this source of variability increases the power. Typically, a matched pairs test has more power than a two-sample test. Now, we didn't actually do up here what we were supposed to do. It says compare the box plots of A versus B. So I have those box plots here. If I just go to my second stat plot, I'm going to turn that third one off, and then I'm going to graph and hit zoom 9 again and trace. Okay, here are the box plots of the two schools. Okay, you might want to sketch them on your paper. What you need to realize, the top one is school A and the bottom one is school B. And what you should notice, and it talks about it up here, if you're comparing those box plots, there are three major sources of variability if you look at the two schools. The variability between the schools, in other words, that's the difference in the center. Remember, the center of a box plot is the median. So school A has a higher median. The variability in the individual students, that is the entire spread. You'll notice school B has a longer box plot. There is more variability in the scores of students from school B. And the randomization variability. So if you pair, this is just looking at the two things separately. If you pair them, it says you get rid of the variability of the individual students. That variability of the individual students gets rid of everything outside that middle 50% for both of them. That's what pairing them, matching them up and pairing, it gets rid of that part of the box plots. So now when you look at those, there is a greater number of students in the middle 50% in school A compared to school B. Okay? You have more students in this middle of the box plot. The middle of the box plot is from Q1 to Q3. And actually, you know, you've got a lot of students in both of them in that upper quartile, but this has more of the students. So the box plots are a little different. There's more variability than when we pair them. So, all right, we are going to do an AP question. It's 2000, number 4, and we're going to do that in class here right now. And then you've got homework assignment with 3 problems on it.